Hey everyone, today we're looking at Unit 4, Lesson 1, Introduction to Quadratics. So we're going to start this lesson by looking back at what we know about lines and linear relations, and that will kind of extend our thinking into a new type of relation we're going to look at called quadratics. So if we look at this equation, y equals 2x minus 5, we should hopefully be able to see that that is the equation of a line from our previous units. We're going to fill in that table of values for this equation. So if it's y equals 2x minus 5, we're going to substitute in a negative 2 for x. Okay, negative 2 times 2 is negative 4, minus 5 is negative 9. So we'll put a negative 9 for our y value. If we sub in a negative 1, okay, negative 2 minus 5 is negative 7. Okay, and we can continue on this process. And hopefully we see a pattern developing here. It's kind of going up by 2 each time. Okay, so what kind of relation is this? When we first, let's plot this table of values. We should be able to look at the equation and see that it's a line, but let's also put it on our graph. So we are at negative 2, negative 9, negative 1, negative 7, 0, negative 5, 1, negative 3, and 2, negative 1. Just get our ruler to make a nice straight edge. Okay, so we can see that this is linear, right, or that it's a line. It says calculate the first difference for the table of values. So our first difference is a new term that we haven't talked about before, but our first difference is another way of saying we're going to take a look at the change in our y values. So remember that delta, that Greek symbol for delta means change in, right? So we usually figure out the change in our y values when we're working to find our slope. But this first difference is going to, again, lead us to this new relation that we're going to talk about today. So if we look at our first difference, I'm just going to make a new column up here called first differences. We get used to this new terminology. And our first differences are, what is the difference between consecutive y values? So what I mean from that is, if I go from negative 9 to negative 7, what's the difference there? Am I increasing or decreasing, and by how much? Okay, so as I go from negative 9 to negative 7, I'm going up by 2. And then I look at the next two. So if I go from negative 7 to negative 5, again, I'm going up by 2, and up by 2. So what does the first difference show us? Well, we can see that our first difference is a positive 2, okay, and it is constant, which means it stays the same, right? If we're saying it's constant, it's the same value, so it stays the same, okay? Oh, stays the same on my bracket there. Okay, if it's constant, then that means that we must have a linear relation. So constant first differences mean it's a linear relation. Okay, and we notice that our first difference in this case is positive. So if it's positive, that means that it's going to have a positive slope, or it's going to open upward. So means positive slope. If it was negative, that means we're going to have a negative slope, or it's going to slope down. All right, so that's what we know about our linear relation, that when we have a first difference that is all the same, that we're going to end up with a linear relation. We're going to take a look at a different kind of relation that doesn't look like a line, and we're going to complete the table of values for this. Okay, so complete the table and graph the relation for y equals x squared minus 5. So I'm going to plug in a negative 2 minus 5. Okay, recognizing here that if I am plugging in a negative 2 for my x, I'm squaring that negative 2. So a negative 2 squared is like saying negative 2 times negative 2, okay, which we should recognize as a positive 4. So 4 minus 5 is going to be a negative 1, and we'll put that here. Okay, and we'll continue on that process. So negative 1 squared minus 5. Well, negative 1 squared is 1. 1 minus 5 is a negative 4. So we'll put that here. Okay, 0 squared minus 5 is going to be a negative 5. So hopefully you can see there, I'm not seeing a pattern like I usually do with my linear relations. So 1 squared minus 5, well, that's going to be a negative 4 again. So I'm starting to actually see some of those same values from earlier in the table. So 2 squared is 4, 4 minus 5 again is negative 1. So let's plot these points. My first point is negative 1. Okay, and I'm just going to label my points here. This is a new relation. Negative 1, negative 4. 0, negative 5. 1, negative 4. And finally, 2, negative 1. Okay, I'm going to connect all my dots with a smooth curve. And you can even extend it because this new relation that we're looking at, it also is going to extend and in both directions, just like a line does. So what kind of relation is this? This is what we call a quadratic relation. This is the new relation we're going to spend the foreseeable future looking at. So it's a quadratic relation. And the curve that we put on a quadratic relation is a parabolic curve. Okay, and we say that it's a parabola. So usually when we say it's a linear relation, we would say it's a linear curve or just a line. Okay, when we say it's a parabolic curve, we would just call this a parabola. So we're going to take a look at our first differences again. Just like we did for a line. So as we go from negative 1 to negative 4, we are going down by 3. So this time we're subtracting 3. As we go from negative 4 to negative 5, well, we're subtracting 1 this time. And if we continue on from negative 5 to negative 4, oh, that shows we're going up by 1. And then negative 4 to negative 1 shows we're going up by 3. Okay, so I calculated my first differences. So we can see that our first differences show us that it's not linear, because our first differences were not constant. So what does the first difference show us? Sorry, that shows that it's not linear. Okay, we're going to now take a look at, well, what do our second differences look like? Because we can just keep calculating our second differences. Okay, so I'm going to calculate my second differences. So I'm going to make a new column here and label it second difference. Our second difference is simply going to compare what's the difference of my first difference values. So instead of looking at my y's, now I'm looking at these values and determining what's the difference between these. So as I go from negative 3 to a negative 1, that's an increase of 2. As I go from negative 1 to 1, this one sometimes trips up students. So think about on a number line. If I'm going from negative 1 to positive 1, I have to go negative 1, 0, positive 1. So that's an increase of 2 as well. And then as I go from positive 1 to positive 3, again, I have an increase of 2 as well. Okay, so my second differences are constant. In this case, they were a positive 2. Okay. So because you can see from our table of values, and I told you based on the shape that it's quadratic, that means that if it is a quadratic, our second differences are going to be constant. So if our second differences are constant, it is a quadratic relation. Okay, and since our second differences are a positive, it shows that the quadratic is going to point up. So the arrows on the end of my parabola point up because the second difference is a positive 2. Okay, and obviously if it was negative, we would be pointing down. So let's now compare the two different equation axes. If we go back and look, we can see that it's probably crossing somewhere around 2.5 for my x-intercept, and we could actually solve for this. We can look at our quadratic. Our x-intercepts hit somewhere around negative, let's say 2.2 and a positive 2.2, just based on my graph. We could actually go back and take a look at this quadratic. We can see our y-intercept is when my x is 0, right? So it's right there at -5 to. All right, so if we take a look at these two equations, I'm actually going to just draw a line, almost like we're putting them in a table. So if we have 2x minus 5, which is the line we just looked at, and the quadratic we looked at was y equals x squared minus 5. The types of relations that each of these are. Well, we said that our first one was linear. Okay, and y equals x squared minus 5 is this new relation we're going to start exploring called quadratic. All right, our x-intercepts. So where does the graph cross the plug-in for y is 0, and we would see that our x-intercept is at 2.5. We're just going to, based on our graph, it's 2.5. Okay, our y-intercept comes from our b value, right? So that's our y-intercept. If we think back to our lines. So our y-intercept is going to be at -5. And then this question comes up a lot because this also tells us what kind of relation we have. What's the highest exponent in this equation? Meaning if we look at our variables, what's the highest exponent on either of them? Well, I have a 1 on my y and I have a 1 on my x. So the highest exponent in this equation is just 1. All right, let's evaluate some of this information looking at our quadratic. So if we create a more accurate number, but just to kind of compare what's going on. So we have an x-intercept at -2.2 and at +2.2. Our y-intercept in this case is again at -5. And then finally, what's the highest exponent in this equation? Well, we have a 1 on my y, but we have a 2 on my x. So the highest exponent for a quadratic is 2. We call this the degree of the equation. So a linear equation has a degree of 1, and a quadratic equation has a degree of 2. So just, again, some more ways to recognize a quadratic versus a linear. All right, so we're going to look at a few more quadratic relations today and identify, just again, what do those finite differences, those second differences show us. All right, so take a minute, pause the video, and see if you can fill out the table of values and then graph this relation, for example, 4. Okay, so here's what your table of values should look like, as well as your graph. So looking at the equation, we see that we have a degree of 2, okay, which should tell us that we have a quadratic. If we look at the graph, it looks parabolic in shape, but let's also look at those first and second differences to kind of confirm our thinking here. So our first difference is we're going to compare the change in our y values. So as I go from a +5 to 0, I'm going down by 5. Then it goes down by 1. Then it looks like it goes up by 3, and then finally up by 7. Okay, so right now my first differences are showing me it's not linear because my first differences are not the same. So if it's not linear, we might as well just move on and take a look at what are our second differences. So as we compare those first differences, what are the differences between them? So as I go from -5 to -1, that's an increase of +4. As I go from -1 to +3, that's also an increase by 4. And that last one is an increase by 4 as well. So what do the finite differences show? Well, they show that our second differences are positive and they're constant, meaning they stay the same. So it's going to be a quadratic relation. And because it's positive, it points up. Right? So our second difference is a +4, it's constant, so it's quadratic, and it points up. So what is the y-intercept? Remember that our y-intercept is going to be wherever x equals 0. So our y-intercept is going to be at -1. Does the relation have a maximum or does it have a minimum? All right, if we take a look, a maximum would represent a highest point on the curve, and it goes on forever. So we can't establish that there's a maximum. But there is a lowest point, okay? That lowest point would be somewhere there. So we can say that it has a minimum. And it looks like that minimum is around So we go down 1, maybe 1.5, so around a negative 1.5-ish. We will learn ways to actually calculate this minimum point, but for now, looking at the graph is fine. Okay, let's take a look at one more table, just kind of continuing to look at a quadratic and how we can identify that it's a quadratic. Pause the video, fill out that table of values, and graph it. After you graph it, go ahead and calculate your first and second differences as well, and then we'll come back together to answer part 2, 3, and 4 of this equation. Okay, so the table of values is filled out, and there's your parabola. You can see that this parabola looks a little bit different because this time it's pointing down, it's not pointing up. Our first differences were all different, so that tells us it's not linear. Our second differences were constant. They were all in -2, so that shows us that we should have a quadratic relation here. So what do the finite differences show? They show that our second difference is negative and constant. So it's a quadratic that points down, right? We have a quadratic that's pointing down. Our y-intercept, once again, comes from wherever x equals 0, or where it crosses the x-axis. So it crosses, or sorry, where it crosses the y-axis rather, right? So it crosses the y-axis right there, so it's crossing at +2. Okay, and then finally, does the relation have a maximum or a minimum? In this case, we have a maximum point. We don't have a minimum because it goes on forever and ever, right? So it continues getting lower and lower. We can't identify one minimum. So it has a maximum, and that maximum happens to be the same as our y-intercept. So it has a maximum at 0, 2, okay? And in this case, it's the same point as our y-intercept. So we'll continue exploring quadratics, but that is it for your note for today.